everyone. In this video, we are quickly going to revise the chapter Some Basic Concepts of Chemistry from cbse class 11. You can use this video to revise the chapter before the exam. The other chapters from class 11 cbse chemistry will also be uploaded in this channel, and to get quick updates, subscribe to our channel. Okay, now let's get into the video. The chapter begins with telling us the meaning of chemistry, that is the branch of science that studies the preparation, properties, structure and reaction of material substance is called chemistry. And they also tells us chemistry was not studied for its own sake, rather it came up as a result of search of two interesting things. One was philosopher's stone, which would convert all base metal, example iron and copper, into gold. The other one was elixir of life, which would grant immortality. The next two pages of this chapter describes how chemistry was practiced in ancient India, and they provide the proof of it. We all know anything which has mass and occupies space is termed as matter. This matter then classified as solid, liquid and gas. Solids have definite volume and definite shape. Liquids have definite volume but do not have definite shape. They take the shape of the container in which they are placed. Gases have neither definite volume nor definite shape. They completely occupy the space in the container in which they are placed. On a macroscopic level, matter can be classified as mixture or pure substance. Mixtures are again classified as homogeneous or heterogeneous. In homogeneous, the components completely mix with each other. In a heterogeneous mixture, the composition is not uniform throughout and sometimes different components are visible. Pure substances are further classified as elements and compounds. Particles of an element consist of only one type of atom. These particles may exist as atoms or molecules. When two or more atoms of different elements combine together in definite ratio, the molecule of a compound is obtained. A fun fact about chemistry is that oxygen and hydrogen, which individually help in burning, when combined with each other form water, which is used as a fire extinguisher. Every substance has unique or characteristic properties. These properties can be classified into two categories: physical and chemical properties. Physical properties can be measured or observed without changing the identity or the composition of the substance. The measurement or observation of chemical properties requires a chemical change to occur. First, let's learn about measurement of physical properties. The International System of Units was established by 11th General Conference on Weight and Measures. This was signed in Paris in 1875. The SI system has 7 weight units. Those are length, mass, time, electric current, thermodynamic temperature, amount of substance, luminosity, and their SI units were meter, kilogram, second, ampere, Kelvin, mole, candela. Many of you might have a slight confusion between mass and weight. Let me make it simple. Mass of a substance is the amount of matter present in it, while weight is the force exerted by gravity on an object. The mass of a substance is constant, whereas its weight may vary from one place to another due to change in gravity. The mass of a substance can be determined accurately in the laboratory by using an analytical balance. Density of a substance tells us about how closely its particles are packed. If density is more, it means particles may more closely packed. Density is equal to mass by volume. Its SI unit is kilogram per meter cube. There are 3 common scales to measure temperature: Celsius scale, Fahrenheit scale and Kelvin scale. Here Kelvin is the SI unit. The temperature on 2 scales are related to each other by following relationship. Fahrenheit scale is equal to 9/5 Celsius scale plus 32. The Kelvin scale is related to Celsius scale as follow. Kelvin scale is equal to degree Celsius plus 273.15. A fun fact about temperature is that negative values are possible in Celsius, but in Kelvin scale, negative temperature is not possible. Since measurement involves recording of data which are always associated with a certain amount of uncertainty, the proper handling of data obtained by measuring the quantity is very important. The measurement of quantities in chemistry are spread over a wide range of 10 power negative 31 to 10 power positive 23. Hence, a convenient system of expressing the numbers in scientific notation is used. The uncertainty is taken care by specifying the number of significant figures in which the observations are reported. The dimensional analysis helps us to express the measured quantities in different systems of the units. Hence, it is possible to interconvert the result from one system of unit to another. This lesson has a lot of numericals. If you all wanted me to solve it, please drop a comment in the comment box. And I would make a separate video for that. The combination of elements to form compounds is governed by the 5 basic laws. The law of conservation of mass. This law was put forth by Antonio Lavoisier in 1789, and it says that matter can neither be created or destroyed during a chemical reaction. Law of definite proportion. This law was given by a French chemist Joseph Proust. He stated that a given compound always contains exactly the same proportion of elements by weight. That means, irrespective of the source, a given compound always contains same element combined together in the same proportion by mass. Law of multiple proportion. This law was proposed by Dalton in 1803. According to this law, if two elements can combine to form more than one compound, the masses of one element that combine with a fixed mass of the other element are in the ratio of small whole number. Gay-Lussac law of gaseous volume. This law was given by Gay-Lussac in 1808. He observed that when gases combine or are produced in a chemical reaction, they do so in a simple ratio by volume, provided all gases are at same temperature and pressure. Avogadro's law. Avogadro proposed that equal volume of all gases at the same temperature and pressure should contain equal number of molecules. At first, this statement was not accepted by most of the scientists like Dalton, but later on, while conducting experiments, this statement proved to be true. In 1808, Dalton published a new system of chemical philosophy, in which he proposed the following. Matter consists of individual atoms. All atoms of a given element have identical properties, including identical mass. Atoms of different elements differ in mass. Compounds are formed when atoms of different elements combine in a fixed ratio. Chemical reaction involves reorganization of atoms. These are neither created nor destroyed in a chemical reaction. Most of the statements proposed by Dalton in his atomic theory is slightly proven wrong later. One atomic mass unit is defined as a mass exactly equal to 1/12 of the mass of one carbon-12 atom. At present, AMU, atomic mass unit, has been replaced by U, which is known as unified mass. Many naturally occurring elements exist as more than one isotope. When we take into account the existence of these isotopes and their relative abundance, the average atomic mass of that element can be computed. Molecular mass is the sum of atomic mass of the element present in a molecule. It is obtained by multiplying the atomic mass of each element by multiplying the atoms and adding them together. Some substances do not discrete molecules as their constituent units and are arranged in three-dimensional structure. The formula used to calculate mass in such a situation is called formula mass. Atoms and molecules are extremely small in size, and their numbers in even a small amount of any substances is really very large. To handle such large numbers, a unit of convenient magnitude is required. Just as we denote 1 dozen for 12 items, score for 20 items, gross for 144 items, we use mole to count entities at the microscopic level. In SI system, mole was introduced as 7th base quantity for the amount of a substance. 1 mole is the amount of a substance that contains as many particles or entities as there are atoms in exactly 12 grams of the carbon-12 isotope. The mass of 1 mole of a substance in grams is called its molar mass. To find the mass percentage of an atom in its given compound, we use the formula. Mass of the element in the compound into 100 divided by molar mass of the compound. As I told earlier in this part of the chapter holds so many numericals. If you want a separate video on that, comment below. A numerical formula represents the simplest whole number ratio of various atoms present in a compound, whereas the molecular formula shows the exact number of different types of atoms present in a molecule of compound. The word stoichiometry is derived from two Greek words, stoichion meaning element and metron meaning measure. Stoichiometry does deal with the calculation of masses of the reactants and products involved in a chemical reaction. Stoichiometric coefficients represent the number of molecules taking part in the reaction or formed in the reactant which gets consumed first or limits the amount of products formed is called as limiting reagents. In performing stoichiometric calculation, we should keep this aspect in mind. The concentration of a solution or the amount of a substance present in a given volume can be expressed in the following ways. 1. Mass percentage. To find mass percent, we use this formula. Mass percent is equal to mass of the solid divided by mass of solution into 100. Number 2. Mole fraction. It is the ratio of number of moles of a particular component to the total number of moles of the solution. If a substance A dissolves in a substance B, their number of moles are Na and Nd respectively. Then the mole fraction of A and B are given as mole fraction of A is equal to number of moles of A divided by number of moles of solution, that is Na divided by Na plus Nd. Mole fraction of B will be like this: number of moles of B divided by number of moles of solution, that is Nd divided by Na plus Nd. Number 3. Molarity. It is the most widely used unit and is denoted by capital letter M. It is defined as the number of moles of the solute in liters of the solution. Molarity is equal to number of moles of solute divided by volume of solution in the liter. Number 4. Molality. It is denoted as the number of moles of solute present in 1 kg of solvent. It is denoted by small letter m. Thus, molality is equal to number of moles of solute divided by number of solvent in kg. I hope this video is useful for you and save a lot of time for you. If you find this video was useful, don't forget to share with your friends. And wishing everyone a best of luck for your exams.